things sometimes when Python doesn't trace back, when you think, you know, if you're so obsessed about everything, I would have traced back in that situation. But hey, I guess if you're allowed, you're allowed. And so there we go. Now you can eliminate or omit the first or last. If you eliminate the first, it assumes the beginning of string. If you eliminate the second, it assumes the end of the string. And why you would do this, I don't know, but that's from beginning to end, so it's the whole string. So whole string, 8 through the end is thon, and up to but not including 2 is mo. All right, so you get that. So that's pretty simple. Once you've got the rest of slicing and the rest of string indexing, the notion of eliminating the first or the last of the colon expression, the first or second of the colon expression, I think is actually pretty intuitive, pretty nice. We've already been concatenating strings together. We overload the plus operator, and there is no space added. Remember, when you're doing print, x comma y, this comma does turn into a space, but that's not what's happening here. There is no automatic space being added, and so we see hello in there, and it just is hello there with no space. And so if we want, we just have to concatenate the space explicitly if we want to put spaces into strings. The problem is if this, you might think it's more convenient to add a space with a concatenation, but then you have to think, well, what about if I want to concatenate things and not put the space in? Then I'd need a different operator. So that's kind of why it works that way. We can use in differently as a logical operator, so we're using it as an iteration structure in for loops, but we can also use it as a logical operator in if statements. So it's kind of like the double equals or not equals or less than or equals or something like that. It's like those guys, and it returns a true or a false. Is n in fruit? So that's a question, and the answer is true. Is m in fruit? No, that's the answer to a question. Is nan in fruit? Doesn't have to be single character, can be more than one character, and the answer is true. And then you say something like, if a in fruit. And so this is the logical value that returns a true or a false, and yes, we found it. So that becomes true in this particular case, so it runs the little indented bit. So in is an operator in this particular situation. In a for loop, in means something different. And we'll use in for other things as operators, as logical operators coming up in a bit. You can compare strings, and this has to do with the character set of your computer, the character set that Python is, but in general, it is lexicographically less than and lexicographically greater than. Uppercase and lowercase are a little weird. I think when we used the max function earlier, the way my computer was set up, uppercase was less than lowercase, but in general, uppercase is less than lowercase. But in general, it's bad to assume case, but there is a deterministic way to sort strings. You can, have something equal to or less than or greater than, and all those operations work naturally. The less than and greater than, you have to kind of be aware of uppercase, lowercase, things like where punctuation sorts less than or greater than letters. That's kind of unpredictable and depends on the character set of your computer, and something you just play with and figure out. If you're doing sorting stuff by first name and last name, as long as the case is kind of the same, if you were sorting Chuck with an uppercase and Glenn, the fact that these uppercases, they'd sort right and these lowercases would sort right, but if you were to subdue instead lowercase Chuck and uppercase Glenn, then that would sort weird. As a matter of fact, the G would come before that. And so case can mess this up, but in general, other than case and special characters and other things, it technically works. It's just hard to kind of predict it. A lot of what we do is use the string library, and so the strings are objects, and we'll talk later about what that really means. And objects have these things we call methods. So a string object has some built-in capabilities, and one of the built-in capabilities that the string object has is, here is a string object, And because greet is a string object, if we said type, we'd see that it was an str. Dot lower says, hey, dear string, make a lowercase version of yourself. It's like calling this function lower and passing greet into it. And then give that back to me. Now it doesn't actually change greet, it gives me a lowercase copy. So here I have hello Bob with an H and a B uppercase, and what I get back in Zap is hello Bob all lowercase. And note that greet is unchanged. So hello Bob is still there. And you can even call these methods on constants. So this is a string object, quote, hi there, quote, dot lower, that says call lower on this bit of string and give me back a lowercase version of it. And so it prints out as the residual return value. This is like a function call. A method call is a kind of special form of a function call. It's a function call where you say the thing dot the function name rather than function name passed in as a parameter. Like len, for example, is non-object oriented. You know, len of x, that's non-object oriented. Object oriented would be x dot something, parenthesis. But, so constants are objects as well, and taking the lower gives us back lowercase hi there. And so that's just one of the things that you can do in the string library. These are built into string variables and constants. They're just always there. As soon as you make a string, they're part of it. And when you do type and it says it's class str, we'll get to object-oriented. Don't worry, we'll get to object-oriented. Okay, and so you can do things like use the type. If you're just, look, this used to say type stir, but it's class stir. Kind of, this is more of an OO. The word class is an object-oriented concept, but it is a string. And you can use the dir, and of course there's extra stuff up here. And this is showing all the different methods or capabilities, things we can do to strings. So, you know, x dot something, parenthesis. Well, what can we do there? This is all of those things that we can do to x's that are built in and come with x's, come with strings when we build them. And Python, of course, has great documentation online for all of these string methods and what they do and how they work and why they work the way they do. And so here's some of that Python documentation. We'll look at a few of these, but you know, don't hesitate to say Python string uppercase, and then I'm like, oh yeah, that is upper, right? And so here's a few things that we can do and use. Some of the ones I use a lot, and we'll look at each one of these things. So the find operation says find me a substring within a string. Right? Find me a substring within a string, so find me the first NA and give me back the position. So that gives me back 2. And then I can say, go find a Z in there. Well, there's no Z, and so it returns me -1. So that's what the find does. So we're going to use this kind of stuff a lot, and we do a lot of looking in strings. Converting things to upper or lower case, there is an upper method and a lower method. So greet.upper. And that means the uppercase NNN is hello Bob. Greet.lower, that means that www is the lowercase hello world. And greet is unchanged. Greet is still hello Bob with upper and lower, because each of these methods basically say, I'm going to give you back a uppercase copy or a lowercase copy of the original thing without changing the original thing. Search and replace is super useful, super duper useful. And it's pretty clean. Here we have a string, and we use the replace method. In this case, we're passing in the old and the new. Bob, replace all Bobs with Janes. And so that takes this hello Bob and turns it to hello Jane. Again, greet is unchanged. Greet is unchanged. And it does more than one thing. So this says go find, well, let's clear that. This says go find all the O's and replace all the O's with X's. And so it goes and finds 2 of them, and then out come 2 X's. And so that really is replace is not just replace the first one, but replace all of them. White space, as we'll see, is a big deal. And white space is not just blanks, although the most common thing, but it's also sort of non-printing characters like tabs and new lines and other kinds of things. And so we have a number of different ways to strip white space. So here we've got some spaces at the beginning and spaces at the end, and we do an L strip, and that throws away the spaces at the beginning. That's the left So that's a left strip. It all takes any, if there's nothing there, it doesn't harm it. R strip means throw away all the blanks on